Hi, now let us discuss about Smart India Hackathon 2024 problem statement solution. Imagine you are in a world where water is no longer a precious resource but a clean and abundant gift. But what if I told you that even the tiniest impurities in water can impact our health and the environment? Today we are diving into a fascinating process that can significantly improve water purification. We will explore how a slow and filtration system works and see what happens when we add fly ash to it. This technique not only cleans water but also helps in reusing a byproduct from the coal industry. Sounds interesting, right? Let's get started by setting the scene with two jars. One is slow sand filtration system, another one is sand filtration with fly ash. One jar is filled with two layers, gravel at the bottom and the sand topping it off. The gravel makes up 30% of the jar while the sand takes up 70%. Now the second jar we have more complex setup. This one start with 30% of layer of gravel and 20% layer of sand and top layer of layers accounts 50%. So we have two jars, each designed for filtering water but configuring differently. Now let us visualize the potential of these setups. Imagine we pour water into both jars as the water begins to filter. The first jar with the gravel and sand, it moves quite slowly, but what happens next is critical. Water exits the jar looking somewhat cloudy. You can still see some contaminants lingering in it. Now let's turn our attention to the second jar with its gravel, sand, fly ash, and combination. As we pour water into this jar, it also filters slowly, but the presence of fly ash changes the dynamics. This jar's unique layer composition is working wonders. When the water comes out, it's strikingly clear and free from most impurities. Hold on a moment. Can you see the difference? What we what we have just witnessed is how the use of fly ash in filtration system enhanced the quality of water. We have compared two simple jars, both purposed for filtration. The first relied on common method, while the second allowed innovation in the form of fly ash. This comparison has shown us two distinct outcomes. One jar offered partially impure water, while the other provided solution that is significantly cleaner compared to first one. These simple experiments demonstrate a powerful principle. Now let us discuss about our second solution, and that is corn cob method. Did you know that humble corn cob, often seen as agricultural waste, can play a vital role in the cleaning of water? Yes, you heard that right. Today we are diving into a fascinating to water filtration using corn cups. This method not only provides an eco-friendly solution to wastewater treatment but also tackles one of the agricultural biggest waste issues. Imagine a world where waste from crops like maize or Z-maize, as scientists call it, returns into a helpful tool for cleaner water. Maize is not just staple food in many countries, including India. It also a crop that generates tons of waste in the form of corn crops. In India alone, states like Karnataka, Andhra Pradesh, and Tamil Nadu contribute significantly to maize um, production, and with that production comes a large amount of corn cob waste. Even animals also doesn't consume these corn cobs because the threat of choking, and farmers also burns these corn cobs, and it leads to air pollution. Now, discuss about working model and setup of this Concop method. Every good filter needs a strong base support. For this purpose, we use 20 sized gravel weighing about 1 kilogram. The gravel should be washed thoroughly to remove any dirt before being placed. Once cleaned, it's laid uniformly over a geotextile cloth, which is important for a drainage. Next comes the second layer, fine sand. Fine sand is a well-known medium in sewage treatment for trapping impurities. 1 kilogram of fine sand is placed over the geotextile cloth above the gravel. This layer is crucial as it is nourishes beneficial microbes that help treat wastewater biologically. After placing the fine sand, we add the third layer, which consists powdered corn cobs. The powdered corn cobs must be cleaned and dried before being layered. This layer should also be evenly spread over the previous sand layer. Now we place another layer of geotextile cloth on the top of the powdered corn cob. Next, fourth layer is activated carbon. Activated carbon is a common absorbent using in many water filtration systems. 1 kilogram of washed ash-free activated carbon is placed carefully over the geotextile cloth. Make sure to spread it out evenly. After that, we follow up with fifth layer of small pieces of corn cobs. These pieces should measure between 5 to 8 centimeters length. Just like before, wash and dry the pieces before placing them uniformly over the carbon layer. Finally, for sixth layer, we use longitudinal cobs. These sections should also be cleaned and dried, just like the previous layers. Ensure they fit snugly together, leaving no gaps. Each of these layers plays a crucial role in filtering wastewater. The multiple layers ensure that contaminants that trapped at different stages of filtration. As the water moves through these layers, impurities are naturally filtered out, leading to cleaner water out. This is not just innovative, but is also a step towards sustainability by utilizing what would otherwise be waste. One major benefit is that corn cobs are widely available and inexpensive, especially in agricultural regions. This method also encourages farmers to find value in waste that they might otherwise dispose by burning. And these are the two methods for mitigating the cost solutions in grey water management. Thank you for watching.